to find the values of trigonometric functions for any angles, and conversely, if you know the value of trigonometric function, how to find different angles. Now we are in a position to introduce inverse trigonometric functions. Sine inverse x. This is the symbol for inverse function sine inverse x. And let me tell you that it is an angle. So sine inverse x is denoted by an angle theta, where x is a real number and theta is also a real number, any angle. So sine inverse x is an angle theta for sine theta equal to x. I repeat, sine inverse x is an angle theta for sine theta equal to x. You already know the domain and range of at least the trigonometric functions. That is, the domain of sine theta, here theta is any real number. Sine theta is defined for all real values. But what about the value of sine theta, that is x? Of course it is a real number, but it cannot be any real number. For example, can you tell me an angle theta whose value of sine theta is 2? No. So what is the range of sine theta? Range of sine theta is minus 1 to 1. So x lies, any real number, but lies in the interval negative 1 to 1. So domain of sine theta is any real number, but the range is negative 1 to 1. So can you tell me now, what is the domain of sine inverse x? Domain of sine inverse x, that is x. Now this becomes the domain of sine inverse x. Domain of sine inverse x is negative 1 to 1. And range of sine inverse x is any real number theta. Similarly, we can define the other inverse functions. Cos inverse x is theta for x is equal to cos theta, and so on, third, fourth, fifth, sixth. But of course, their domain and range will vary. So we'll come back to the domain and range of all the trigonometric functions one by one after some time. Let me take some simple examples of inverse functions. Say for example, can you tell me what is the value of sine inverse half? As per definition, inverse function is an angle. So sine inverse half is an angle theta for sine theta is half. And what is that angle whose sine is half? It is 30 degree or pi by 6. So we may safely say that sine inverse half is pi by 6. Similarly, what is cos inverse 1 by root 2? Can you directly tell me? That is, what is that angle whose cos is 1 by root 2? Cos 45 degree, you know, is 1 by root 2 or pi by 4. So cos inverse 1 by root 2 is pi by 4. What about tan inverse root 3? Tan inverse root 3 is again an angle, the value of whose tan is root 3. So what is that angle when tan theta is root 3? Tan theta is root 3. For which angle? Theta is pi by 3. So can we conclude that tan inverse root 3 is pi by 3? Similarly, of course, we can have the negative real numbers, but that will follow. Now before I want to discuss it all over again. In Unit 1, you have already seen what is the value of sine 30 degree. It is half. What is the value of sine 150 degree? Half. What is the value of sine 390 degree? It is half. And that of minus 210 degrees, that is also half. It means here, if I discuss it in terms of function, if theta is 30 degree or 150 degree or 390 degree or minus 210 degrees, in all such cases, the value of sine theta remains 1. So what kind of function is this? What do you call such kind of function? It is many one function. It is many one function. For different angles, we may have the same value of sine theta, and similarly for other trigonometric functions. Conversely, just look at the reverse. If x is half and the function is inverse function, that is sine inverse x. So that way, if we just see the two tables, sine inverse x means sine inverse half means particularly sine inverse half means an angle whose sine is half. So as we have seen in the previous table, it could be 30 degree or 150 degree or 390 degree or minus 210, or in terms of radian if I say pi by 6, 5 pi by 6 and so on. Do you think it is a function? Here, to each value of x, that is half, it corresponds to many different angles. It is not a function, because to each, if f is a function from set A to B, if to each value of set A, if each element of set A corresponds to a unique element of set B. So the definition of function fails here. So should I take that inverse function I can't define? Or can we make some amendments, some restrictions on the values? So let us discuss this with the help of graph. As already you know, what is the requirement of a function to be invertible? Why do I use here the term invertible? Because basically we had earlier a function sine theta, and now we are taking the inverse trigonometric function. So we have to use the condition of inverse functions. And what is the condition? A function f is invertible provided it is bijective, that is 1, 1 on 2. So sine inverse x and other functions, other inverse function can only be defined provided they are 1, 1 on 2. Let's see how can we make, say, sine inverse x and similarly other functions 1, 1 on 2 with the help of graph. First, I will discuss the graph of sine theta and then inverse function. Thank you.